This talk is on intermolecular forces and the properties that they induce. So far we have talked about polarity. We've worked with how molecules have polarity. This has led us to intermolecular forces, IM forces. Now those intermolecular forces will actually lead us into certain properties that change. So we're going to look at those today. And so we're going to focus mostly on the properties. I'll do a little bit of review of these intermolecular forces as well. So the first thing we have to establish that's really important is states of matter. So going from a solid to a liquid, solid here, liquid here, gas here, is something that we observe as a different type of property. So for example, going from liquid to gas we call boiling. So we call it the boiling point. We can look at boiling point, we can look at evaporation, we can look at freezing points, all these different properties that are affected by intermolecular forces. Now, this slide has a lot of information on it. You don't need to write most of this down. So I'm just going to cross kind of this stuff out for now. We're going to cover that in our next unit. What I want to focus on is the states of matter that these are in here, solid, liquid, gas, whatever it is, are determined a lot by the strength of the attractions between the particles. So those are those intermolecular forces. The hydrogen bond, the dipole-dipole, or the London dispersion. So looking at these intermolecular forces, they're pretty weak forces. So I covered that in the last talk. But here we have a intramolecular force, a covalent bond. Then we have between the two, here we have the intermolecular attraction. This bond here is much stronger than the weak intermolecular attraction. So the thing that holds these two atoms, this one here and this one here, or this one here and this one here, what holds those together is much stronger than what holds the two particles together, the two hydrochloric acid molecules. So this bond strength is weaker right here between the molecules. However, it does still affect physical properties. So we're going to look at boiling point, melting point, viscosity. We'll talk a little bit about vapor pressure, not a whole lot. And in lab tomorrow, we're actually going to look at evaporation, which is the same thing as boiling in terms of its process. Now, just to review the different types of bonds here, we have a dipole-dipole, hydrogen bond, and London dispersion. So you should know by now the strongest one, I'm going to put a 1 next to the strongest one, hydrogen bond. Dipole-dipole are the second strongest, and dispersion are the third. So this is going to affect how things boil. So for example, with hydrogen bonds, if there's a lot of hydrogen bonds, in the case of water, for example, it's going to have a high boiling point. In the case of dispersion forces, these would have low boiling points. And dipole-dipole would be somewhere in the middle of boiling points. And this is just because this particle here, I'm going to highlight in green, this guy here and this guy here are kind of middly attracted to each other. In this case, they're stronger attracted to each other, so it's harder for those to change from a liquid to a gas. In this case with London dispersion, they are held the least strong together, and so as a result those boil much easier. I will say that these can be a little bit stronger depending on the size. So these are size dependent in the dispersion ones, and larger equals stronger force. So this molecule here will have a stronger force than this one would here. This slide basically just talks about how molecules, when they interact with each other, the more they interact, the strength of those attractions affect many physical properties. And we'll look at some of those. We'll talk about those in class for the next couple days. One of them is viscosity. I don't think you need to write a lot of this stuff down, but here's a really good bullet point. Viscosity increases with stronger intermolecular forces and decreases with higher temperature. So this part about intermolecular forces is important. Viscous liquids. Surface tension's a neat one. So like a water strider here or water bug, they are able to stay on top of the water because there's these surface tension forces, the intermolecular forces, that allow him to stay on top of that water here and not sink. There's no quiz for this video, so enjoy. Tomorrow's lab, we're going to focus on evaporation of different types of bonds. So hydrogen bond, London dispersion bonds, and dipole-dipole intermolecular bonds.